Math Module 4, Decimal, Binary, Octal, and Hex. Decimal, binary, octal, and hexadecimal are numbering systems. Simply put, a numbering system is a way to represent numbers. We're used to using the base 10 numbering system, which is also called decimal. The hexadecimal numbering system is a base 16, the octal numbering system is a base 8, and the binary numbering system is a base 2. You've counted in base 10 all your life. Quick, what's 7 plus 5? If you answered 12, you're thinking base 10. Let's take a closer look at what you've been doing all these years without ever thinking about it. Let's look at counting. You go through the digits, and once you hit 9, you have no more digits to represent the next number. So you change it back to 0, add 1 to the tens digit, giving you 10. The process repeats over and over, and eventually you get to 99, where you can't make any larger numbers with 2 digits, so you add another, giving you 100. The following chart will help you visualize the base 10 numbering system. On to base 8, also called octal. Base 8 means just what it sounds like. The system is based on the number 8 as opposed to the number 10. Remember how in base 10 we had 10 digits? Now in base 8 we're limited to only 8 digits. There is no such thing as 8 or 9. We count the same way we normally would, except with only 8 digits. This chart should help you visualize that. You should notice a similar pattern to before. After we get to 7, we run out of different digits for any higher number. We need a way to represent 8 for something else. So we add another digit. We change the 7 to 0, end up with 10. Our answer of 10 in base 8 now represents what we would normally think of as 8 in base 10. Let's try converting from base 8 to base 10. Let's look at a wordier example now. John offers to give you 478 cookies. Jane offers to give you 4,310 cookies. Whose offer do you take? As we saw when counting, the 4 in 478 represents the number of groups of 8. This makes sense since we're in base 8. So in total, we have 4 groups of 8 and 7 groups of 1. If we add these all up, we get 4 times 8 plus 7 times 1, or 3,910 cookies. So the 478 cookies is the exact same as 3,910 cookies. Jane's offer seems like the best. How do we deal with any base? It's important to be able to apply the concepts we've learned about base 8 and base 10 to any base. Just as base 8 has 8 digits and base 10 has 10 digits, the base has the same number of digits as its base. So base 5 has 5 digits, base 7 has 7 digits, and so on. Now let's see how we can find the base 10 value of any number in any base. Say we're working in base B, where B can be any positive integer. We have a number, D4, D3, D2, D1, D0, where D is a digit in a number. Our base 10 value is D4 times B4 plus D3 times B3 plus D2 times B2 plus D1 times B1 plus D0 times B0. Base 16 is also called hexadecimal. It's commonly used in computer programming, so it's very important to understand. Let's start with counting in hexadecimal to ensure we can apply everything we've learned about bases so far. Since we're working in base 16, you have 16 digits, so we count 1 through 9, and yikes, we run out of digits, we need 6 more. We could use a circle 10. The truth is it would make it harder to type. Instead, we use letters of the alphabet, starting with A and continuing to F. Because there are more than 10 digits in a hexadecimal, it's written like this. base 2. On to the famous base 2, also called binary. While everyone knows that binary is made up of zeros and ones, it's important to understand that it's no different mathematically than any other base. There's an old joke that goes like this: there are only 10 types of people in the world who understand binary, and those who don't. In other words, the expression 1, 0 is not 10, but 1 and 0, which is binary, is 2. So here's how we count in binary. Let's look at some tricks and tips. Normally, when converting between two bases that aren't base 10, you would do something like this. Convert the number to base 10, then convert the result to the desired base. However, there's a trick that will let you convert between binary and hexadecimal quickly. First, take any binary number and divide its digits into 4 groups. Say we have the number 10, 11, 10, 12. Divided up, it's 10, 11, 10, 01. Notice we can add the extra zeros to the front of the first group to make it in groups of 4. And we find that the value for each group is in its separate number that gives us 5 and 13. Finally, we simply use the corresponding hexadecimal digits to write out the base 16 number, 5D.